Hello students, in this class I will discuss about aromatic, electrophilic, substitution reaction. Okay. Now, before I proceed to aromatic electrophilic substitution reaction, I want to give stress on these two words, aromatic as well as electrophilic. What are called aromatic compounds? When a cyclic compound satisfy the following three criteria, these are called aromatic compounds. What are the three criteria? That all aromatic compounds should satisfy three criteria for aromatic compounds are: number one, the compound must be cyclic. Number two, it should be planar. Number three, must have (4n + 2 pi electron). Value of n is equal to 0, 1, 2, etc. Now a pi bond is made up of 2 pi electron. N can be 0 also. So the cyclic compound, a planar cyclic compound with 2 pi electron or 1 pi bond may be called as an aromatic compound. So what is the simplest aromatic compound? I'll discuss these things first. Now suppose look at the case of this. Suppose think of the case of this. It's called cyclopropynyl cation. In this case, see, it is cyclic, whether it is planar or not. This double bonded carbon are sp2 hybridized. Planar. This positive charge carbon is also sp2 hybridized. So the whole system is planar. So cyclic and planar holds true. It consists of 1 pi bond. So 4n + 2 equals to 2. 1 pi bond means 2 pi electron. 4n is equal to 0. So n is equal to 0. So cyclopropynyl cation is simplest aromatic compound. Actually it is an cation, aromatic compound which is positive charge cation. Now when a aromatic compound is carrying charge, it is called quasi-aromatic system. So it is, as it is charged, so cyclopropynyl cation is called quasi-aromatic system. Now let us discuss the other aromatic compound in which we should discuss the case of substitution reaction. Now think of the case of your benzene. Benzene is a cyclic structure of 6-membered ring with alternate single and double bond. It can be represented by two such structure. Combination of these two structure. In these two structure, position of the atoms is unchanged, but position of electron is changed. So this is called aromatic. This is aromatic and the phenomenon is called as resonance. Due to resonance, benzene can be represented by two such resonating structure. Due to resonance, all carbon in benzene are equivalent. The two structures are called resonating structure. Okay, now I will discuss whether benzene is aromatic. If it is aromatic, how it will undergo substitution reaction, etc. Let us see. It is a cyclic compound. So first condition is fulfilled, planar, because all the carbon are sp2 hybridized, hence it is planar. Next, 4n plus 2 in this case will be equal to 1 pi bond consists of 2 pi electron. 4n plus 2 is equal to 6 in case of benzene. So 4n is equal to 4. So n is equal to 1. As n is 1, since benzene is called an aromatic compound. Now, due to extra stability of aromatic compound, the aromatic compound, though it contains pi bond, it doesn't want to lose its aromaticity. Okay, as a result, unlike ordinary open bonded double bonded hydrocarbons such as alkene, which is undergo addition reaction where it become unsaturated to saturated one, so benzene, unlike ordinary hydrocarbon, does not undergo addition reaction. So first criteria, aromatic compound do not undergo addition reaction. Why? As in addition reaction, aromatic character is lost. Because of extra stability, benzene, unlike ordinary double bonded unsaturated hydrocarbon, does not undergo addition reaction. Now, what kind of reaction benzene undergo? Now, benzene is a 6-membered cyclic ring with alternate single and double bond. Double bond consists of pi bond. Pi bond is consists of pi electron. And all the carbon attached with an hydrogen. Because of extra stability, benzene, I told you, never undergo addition reaction. But due to its high electron density, due to the 3 pi bond, when an electrophile approach to benzene, what are electrophile? Electrophiles are electron seeking species. Seeking species carrying positive charge. Students, please listen carefully. Okay, because of high electron density of pi bond, it's readily attacked by an electrophile. Now, if when an electrophile attack the benzene nucleus, what happens? The reaction, electrophilic addition reaction benzene takes place in 2 steps. Suppose an electrophile as X plus approaches to benzene nucleus. This is plus. This is called electrophile. Or in a covalent molecule, if the central atom is incompletely octet, it want to accept a pair of electron. So all of them called as electrophile. So electrophile basically are what? Philes are electron seeking species who are they? H plus, Cl plus, NO2 plus, or SO3, though neutral molecule, also act as an electrophile because the pi bond breaks up where the sulfur of SO3 carry positive charge. All of them as sulfur carry positive charge due to movement of pi electron towards oxygen, the double bond breaks up where sulfur carry positive charge, hence all of them called as an electrophile. Now what happens when an electrophile approaches to benzene nucleus? Very very important part. Listen carefully. Everything will be explain it to you. Suppose it is a benzene and electrophile X plus. X plus in general can be anything, Cl plus, R plus, etc. When approaches to benzene nucleus, what happen? The double bond attack X plus. It formed an intermediate like that. The intermediate is called cyclopentadiene cation. My question is, though if it is stable one, it is not an aromatic, so it is unstable, so why it will be formed? The reason is that the carbocation formed is resonance stabilized. I am explaining this to you. Why it is formed? Because initially, though it is stable, from stable it will become an unstable, it is formed. Why? Because the carbocation formed is resonance stabilized. Because the precondition of resonance is that double bond, single bond, positive charge are in conjugated system. So double bond moves over here. So it has a structure like that. Actually, look at. Due to resonance, the carbocation formed is stabilized. And moreover, when the hydrogen gives its electron to the benzene nucleus, in such case, again it attains aromaticity where 1x is replaced by a hydrogen. The energy released is so much such that it is replaced by X. So two dominating factors for electrophilic substitution reactions are: initially the carbocation formed is resonance stabilized. Next stage, when H replaces by X, the energy released is so much, so the reaction takes place. So two steps. First an intermediate is formed, then loss of hydrogen. Now according to kinetics, the rate determining step is the slowest step. In the reaction takes place, substitution reaction energy profile takes place this way. Suppose it is the energy, this is the progress of the reaction. The reaction takes place in two steps. It is a step 1, step 2. In step 1, the intermediate is formed. In the step 2, what happened? Hydrogen gives its electron to the benzene, H replaced by X. So it is the formation of the pentadienyl cation is the slowest step. So it is called rate determining step. A rate determining step is the formation of the carbocation. Later on, it loses H. In this case, activation energy is slow in the next step. So the process is fast. Actually, this reaction, the replacement of H by X is fast. It's found to another case also when you replaces H by D, such as if it is D, in this case with X plus, the replacement of, in the previous case it was H by X, in this case it will be D by X. it doesn't show primary kinetic isotopic effect. That means replacement of H or D is fast. That means whether it is H or D, that doesn't matter. It is a fast process. So formation of the carbocation is the rate determining step, and this is the key for a compound undergo electrophilic substitution reaction. Now, if I want to say in a bit detail, see, it is a two-step process though. Step 1 is slow, step 2 is fast. Step 1 is slow. In step 1, both benzene and electrophile takes place. So aromatic electrophilic substitution reaction will be second order substitution reaction. Aromatic electrophilic second order substitution reaction, because in the rate determining step both benzene nucleus as well as the electrophile takes part. Because in competitive exam they will ask you question like that. So electrophilic substitution reaction in benzene are what kind? Generally it is the AR, aromatic AC, electrophilic substitution second order reaction. There are the cases when it undergo aromatic electrophilic substitution first order or nucleophilic reaction also, but I will discuss it later on. Let us proceed first electrophilic substitution reaction. So as in the rate determining step both electrophile and benzene takes place, hence it is an example of second order reaction. So aromatic electrophilic substitution reactions are second order called ARSE2. Second most important question, electrophilic substitution reaction does not show primary kinetic isotopic effect. Okay, because of that, whether it is H or D, that doesn't matter. It hardly takes part. It hardly matters. So first step is the attack by electrophile, hence called aromatic electrophilic second order reaction. Because in the first case activation energy is fast, rate is slow, but in the second stage it is fast. Now, if it undergoes substitution reaction, its aromatic character remains lost. This is the key reason why benzene undergo electrophilic substitution but not addition, because it want to retain its aromatic character. Now I'll discuss some of the prominent electrophilic substitution reaction takes place in benzene. I am discussing one by one all of the generally electrophilic substitution reaction which takes place in benzene. Let us see one case. Think of the case of halogenation. For halogenation, it can be one hydrogen can be replaced by Cl, Br or I, not by F, because fluorine is so electronegative, it is difficult to obtain F+. Because with chlorine, in order to produce electrophile, FeCl3 is used. FeCl3 acts as a Lewis acid. It accepts the pair of electron forming Cl+ and FeCl4 minus. This Cl plus attack benzene to form an intermediate. Step 1. Plus, now pentadienyl cation gives this hydrogen to benzene. So H replaced by Cl. Remember, all carbon in benzene are equivalent though. So it is not necessarily to substitution always takes place in here. It can take place in any out of the 6 carbon atom, as all carbon in benzene are equivalent. Hence, first substitution can take place on any carbon atom. And the product is called what? Chlorobenzene. This is the case of halogenation. Let us discuss another substitution reaction when H replaced by NO2. How it's possible? Benzene. I am expressing benzene this way. You can write benzene that way also. As all carbon in benzene are equivalent, so you should see benzene is written this way with a circle inside it, because all carbon in benzene has single and as well as double bond character. Hence, it is a cyclohexane ring with a ring inside it, as all carbon in benzene are equivalent. Hence, it is written cyclohexane ring with circle inside it. Now, I'll discuss another electrophilic substitution reaction, which is called nitration reaction. For nitration, what are the reagent? For nitration, I should use HNO3 and H2SO4. HNO3 I am written this OHNO2 plus H2SO4 as HHSO4. Because my intention is to produce a electrophile. See, HNO3 and H2SO4, both of them are acid, but in presence of H2SO4, HNO3 act as a base. Why? Which kind of base? Bronsted base. Because the H given by H2SO4 accept by OH of HNO3 produces OH2 plus HSO4 minus. Now oxygen takes the bonding electron, produces H2O plus NO2 plus HSO4 minus. In this case, it is called as Bronsted acid. Very, very important concept. Any hydrogen containing species which gives hydrogen is called Bronsted acid. On the other hand, any species which accept H plus is called Bronsted base. Hence, in presence of HNO3, H2SO4 acts as a Bronsted acid, HNO3 acts as a Bronsted base. HNO3 accepts the H plus from H2SO4, produces NO2 plus. This NO2 plus attack benzene to form this intermediate. To form this intermediate with a plus over here. In this case, it gives its bonding electron to forming nitrobenzene. These are the two examples of electrophilic substitution reaction takes place in benzene. So we have done two substitution. One is halogenation, one is nitration. Just one more case I will discuss for today's class. Next class I will discuss, upload more such substitution reaction. Suppose it is the case, in this case, hydrogen in benzene replaced by alkyl or acyl group. The reaction has a name called Friedel-Crafts reaction. I am explaining the mechanism of this, how the reaction takes place. It is benzene. It was treated with, suppose CH3Cl I have taken as an alkyl halide. It is treated with AlCl3. Very specific case I am discussing. Next I will do the case of general case. Aluminium is incompletely octet, act as a Lewis acid, which accept the electron from chlorine. As a result, the intermediate is formed this way with CH3H, positive charge over here. Now H gives its bonding electron. In this case, one hydrogen replaced by methyl group, to called as an electrophilic substitution reaction on benzene, when hydrogen replaced by methyl group to form methyl benzene, which is known as toluene also. Okay, let us up to this for today's class. Next I will upload more such videos.